How could a so-called primitive society have achieved such sophisticated stone carving techniques? Check out this block right here. Something really cool about this one. So what is going on here?
Imagine you are standing in front of some stones that are thousands of years old. At first glance, they just look like big stones. But as you look at them more carefully, the story starts to get a little strange. The cuts, grooves, and angles made on these stones look so clean and so similar, as if they were not simply carved by hand, but made according to some fixed method. The question is, if the people of that time made them, then how did they achieve such similar geometry? We usually understand history through books. A book tells us who the people were, when they lived, and what they built. But what if the stones themselves are telling us something different? And this is where the story of Pumapunku becomes interesting, because some things found at this place are not just strange to look at, but when you measure them carefully, the questions become even bigger. In this video, we will slowly go towards those questions and see what came out when these stones were looked at, not just as ancient construction, but as a complete system. And believe me, before reaching the end, you will feel several times that maybe we were asking history the wrong questions. Before we move ahead in the video, subscribe to the channel so you can watch such videos first. If we want to understand the story of Pumapunku, then first it is important to understand the story that history and archaeology have been telling us so far. Pumapunku is a very special site connected to the Tiwanaku civilization. It is believed that the Tiwanaku culture had already become quite developed in this area around 1,400 to 1,700 years ago, and reached its peak between around 500 and 900 CE. This was not a small civilization. They developed ways of farming at such high altitudes, where weather and frost could be a major problem for crops. They also used methods to manage water and make use of the land that required good planning and a lot of hard work. Not only that, organizing the work of thousands of people across such a large area was itself a major achievement. At its peak, the influence of Tiwanaku is believed to have spread across such a large region that its population may have reached several 100,000 people. Now let's come to those massive stones of Pumapunku. According to the accepted explanation, these stones were brought from different places around the area. Some of the red sandstone is believed to have come from sources located around 10 kilometers away towards the Copacabana Peninsula. Then these stones were shaped with stone hammers, copper chisels, sand-like abrasive materials, and above all, a lot of time and hard work. Archaeologist Alan Colata worked on Tiwanaku for a long time and tried to show how capable this civilization was at organizing large-scale labor and engineering. So, at first glance, the story makes complete sense. There was a developed civilization. They had many people, resources, and time. They worked together, carved the massive stones, and created an impressive construction. But this is where a question comes up. If this is the whole story, then where is the answer to the simplest question? How did these tools produce such geometric results? Now the most interesting part of the story begins. Because the question is not whether the people of Tiwanaku had enough time to work hard. The real question is, what kind of tools did they have that could create the work we can see on these stones? Here, we first have to talk about copper. On the Mohs scale, the hardness of copper is considered to be around 3. On the other hand, some of the stones used at Pumapunku are said to have a hardness of around 6 to 7. Stones like diorite can be even harder than this. Now understand this in simple language. If you have a piece of metal in your hand that is much softer than the stone you want to cut, then under pressure, that metal itself will start wearing down and changing its shape. It will not easily make deep cuts into the stone. That means shaping hard stone with a copper chisel was not an easy task by itself. Of course, one answer can be given here. Sand may have been used. Sand can work like an abrasive, and by continuously rubbing it, the rough surface of a stone can slowly be made smooth. And if you have a lot of time and a lot of people, then this work starts to seem even more possible. But the problem does not end there, because Pumapunku does not only have smooth surfaces. There are deep and clean internal angles, grooves that appear parallel to each other, and in some places, holes that appear to have almost the same diameter. Slowly rubbing a rough stone until it becomes smooth is one thing, but creating such regular geometry again and again is something completely different. This is where the explanation of a lot of time and patience starts to become a little weak. And this is not some imaginary mystery. The question itself is present on the surfaces of those stones. For the past century, people have tried to explain these different anomalies in different ways. But the real change came when someone stopped looking at these anomalies separately. Until now, we have been looking at the things at Pumapunku separately. Somewhere there is a groove, somewhere there is a hole, somewhere there is a flat surface, and somewhere there is a strangely shaped stone. Different questions and different answers for everything. But think about it. What if all of these were looked at together? This is where the story takes a new turn. Imagine that all the available information about Pumapunku is placed in front of a single system. Every stone's scan, every angle, every measurement, every small and large distance, and every tolerance. Not just pictures, but point clouds from laser scans, meaning millions of coordinates present on the surface of the stone. Along with this, there was also data about the hardness of the stone, the width and depth of the channels, the diameter and depth of the holes, the dimensions of different blocks, and the spatial relationships between them. But one thing was very important here. This system was not told beforehand who built Pumapunku. It was also not told what tools the people of that time should have had. It was not given the old archaeological debates, no fixed theory, and no answer that it had to prove correct. It was simply given the data. And the question was, what are you seeing and how was it made? When humans look at an ancient place, there are already many things in their minds. They have read in books which civilization it was part of, what tools were used at that time, and what was considered possible in that period. But the machine did not have such a story. For it, a stone was simply a collection of coordinates, angles, measurements, and patterns. And perhaps this was the most interesting part of this entire analysis. Because when it started comparing different stones, the first things it noticed were the things that humans had been looking at for years, but still reading as separate pieces. And the similarity that appeared in these blocks took the whole story in a new direction. Now we come to those H blocks, where the story starts to become truly surprising for the first time. When these blocks were compared with each other, it was not just that their shapes were similar. In the comparison of dozens of pieces, the angles inside them, the depth of the grooves, and the ratios of different sections repeatedly appeared to be the same. In other words, it looked as if each stone had not been made separately, but had been made using one fixed design or a common template. And there is one more thing worth noticing here. These blocks are not lying today in their original positions the way they may once have been placed. Earthquakes, centuries of looting and weather have moved many of the stones. Even then, this similarity in their geometry can still be seen. Now the question is, could all of this have been made by hand? Theoretically, many things are possible. So it would not be right to directly call it impossible. But according to the analysis being discussed here, the possibility of producing such repeatability by hand was considered extremely low. The original analysis estimated it to be less than 1 in millions. This is where a comparison with an engineer becomes interesting. When the engineer was told about these measurements, they said that if parts with this level of consistency came from a modern factory, they would assume that they had been made by a numerically controlled machine, meaning a machine that can repeatedly make almost identical parts according to a digital specification. But here, The case was about stones that were thousands of years old, and the thing that attracted the most attention was tolerance. According to the engineer, the precision of these pieces was not just enough to meet the requirement. It looked like the makers were going even beyond the standard they needed. Meaning, perhaps precision was not just an advantage. Perhaps precision itself was the purpose. But if precision was the purpose, then the next question was even bigger. How precise were their surfaces? After the similarity of the H-blocks came to light, the next question was straightforward. If these stones were made with such precision, then how flat were their surfaces actually? To the eye, these surfaces already look completely straight and flat. Even when you run your hand over them, you do not feel any major bumps. But our eyes and hands have their own limits. A difference this small may not even be felt by a human. This is where point cloud scanning becomes useful. When the surface of the stones was scanned in high resolution and mapped using millions of points, researchers tried to see how much the actual surface differed from a perfect plane. And this is where a surprising measurement appeared. According to the analysis we are talking about, in some surfaces, this difference was reported to be a fraction of a millimeter. The deviation was so small that the researchers even checked their instruments again before trusting the measurement. Now, to understand this, let's take a simple example. If you want to make something extremely flat today, a hammer and some soft blade are not enough. For this, you need a known flat reference surface. Then, with the help of an abrasive material, the surface is repeatedly checked and polished against that reference. Wherever there is even a small bump, it is slowly removed. This process is called surface plate lapping, and it has been very important in precision manufacturing. But an interesting question comes up here. If you have to make such a reference surface for the first time, then what perfect surface will you check it against? In modern precision engineering, techniques like the three-plate method were developed to solve this problem, and they were systematically used in the 19th century. Now think about it. If the builders of Pumapunku actually achieved this kind of functional flatness, then where did their reference surface come from? But the flat surface was only half the story. The real clue was hidden in the small holes along the edges of the stones. Until now, we have talked about the H-blocks and their surfaces, but some of the small holes made along the edges of the stones may be an even more interesting part of this whole story. At first glance, these holes look completely normal. Someone might think they were for decoration, while someone else might think that perhaps a peg or fitting was once placed inside them. But when their measurements were studied carefully, the story started to look a little different. The diameter of these holes was said to be quite similar in many places. Their depth also showed a certain consistency. Not only that, a repeating relationship could also be seen between the diameter and depth, as if each hole had been made to a fixed measurement. Now another interesting point comes up here. In the original analysis, the variation in these holes was compared with work done using a modern power drill. The claim was that in some measurements, the deviation was even smaller than drilling done today by an inexperienced operator. But the real clue was on the inner walls of the holes. There, slight spiral-like grooves can be seen. These grooves can help us understand how fast the tool was rotating during drilling and how quickly it was moving forward. When drilling by hand, it is not easy to keep the pressure and movement completely constant. Sometimes the speed will increase a little, and sometimes it will decrease. So naturally, some variation should also appear in the grooves. But in the analysis being discussed here, the pitch and slope of the spiral grooves were described as quite regular. In other words, a pattern that looks like drilling done with controlled rotation and controlled feed. An engineer looking at the measurements said that if these numbers had come from a modern machine shop, there would be no particular reason to immediately doubt them. But remember, the engineer did not say who made these holes or when they were made. They only compared their geometry. And this is where For the first time, three different anomalies, the H-blocks, the flat surfaces, and these holes, started telling the same story. Until now, we had three different things in front of us: very flat surfaces, holes made in a similar way, and the surprising similarity of the H-blocks. But if we look at them together instead of separately, the picture starts to change, because their measurements were not completely unrelated to each other. A kind of relationship could be seen between many dimensions. The width of a channel had a relationship with the depth of a groove. The spacing of some holes seemed to align with the module of the H-blocks, and the raised part of one block seemed to be made to fit into the groove of another block. In other words, these stones were not just beautiful or complicated shapes to look at. They looked like they were made to fit, lock, and seat together. To understand this in simple language, it is like how different parts of a building are prepared in a factory according to fixed measurements, and then taken to the site and joined together. That is why the word prefabrication becomes interesting here. However, this does not mean that there was actually something like a modern factory at Pumapunku. This is only a possible interpretation based on the geometry. And here another difficulty comes up. Pumapunku is located at an altitude of around 12,000 feet. At such a place, forget about modern manufacturing facilities, even organizing the necessary resources, and heavy work according to the standard interpretation would have been a major challenge. Even then, a pattern like a common measurement or controller unit was claimed to appear in the geometry of the stones. The most interesting thing was that this was not limited to just one block. The same module seemed to repeat between different features across the entire site. If this interpretation is correct, then it does not only mean that the craftsmen were highly skilled. It could mean that they had a shared measurement system that was already fixed. But now the question had changed. If a shared measurement system was controlling the whole of Pumapunku, then the next question was not what this unit was. The question was this unit only found here? Until now, whatever we had found was within the boundaries of Pumapunku itself. But when researchers started looking for this supposed common measurement or module in other places, the story suddenly took a major turn. First, it was looked for in nearby Tiwanaku. If the same measurement appeared there again with small differences, it would not be very surprising. After all, both places are considered to be connected to the same culture, roughly the same period, and possibly the same builders. But after this, the researchers took another step forward. They expected that as soon as they moved outside the altiplano, this pattern would disappear. After all, a measurement system could be connected to one particular region and one particular culture. But according to the original analysis, that did not happen. The claim was that similar relationships could also be seen in the measurements of some other stone sites located thousands of kilometers away. And the problem was that these places did not all belong to the same culture. Their time periods were different, their people were different, and according to accepted history, direct contact between many of them has not been proven. Their languages were different. Their calendars were different. Even their religious beliefs were different. So then, how could the same measurement appear? Here, it is very important to understand one simple thing. Measurement is not a natural thing. A measurement does not form on its own in the ground like a mountain or a river. Measurement is an idea. Someone has to decide it. Then, it has to be taught, remembered, and passed on to the next generation. And if two cultures that are very far apart use the same standard, then it is natural to ask how that knowledge finally reached there. Now the researchers had three possibilities in front of them. Either it came from some ancient common source, or it somehow passed from one culture to another, or the machine had seen a pattern in different sets of data that was actually just a coincidence. And the third possibility was the most uncomfortable one. Now that the claim of the same measurement appearing in different places had come forward, the first important question for the researchers was this really a pattern, or did it only look like one? Three possibilities could be considered. First, maybe different cultures learned this measurement from some even older tradition. Second, it could be that at some point one culture passed this knowledge to another culture, even though today we do not have evidence of direct contact between them. And the third possibility was both the easiest and the most uncomfortable. Maybe the machine had simply found a pattern in random data. That is why the analysis used a model of random independent construction to try to see how likely it would be for such measurements to appear so many times and so closely in different places by chance. In the original script, the result was described as being almost zero. To understand this, think of a simple example. Imagine tossing a coin and having it land exactly the same way hundreds of times in a row. Mathematically, you can say that it is not completely impossible, but as the pattern keeps increasing, it becomes harder to consider it just a coincidence. Then an engineer was shown the measurements from different places, but was not told where the data had come from. His first reaction was that maybe all these parts had been made in the same facility and were following one specification. Then, when he was told that these measurements came from stone sites on different continents and from different periods of time, the question became even bigger. This is where one word came up: descent. Meaning, it is not necessary that the measurement simply spread from one place to another. It could be that it came down from some older source. And if that is the case, the direction of the story suddenly changes. Now, we did not have to look toward the future and ask how this knowledge spread forward. We had to turn back and ask where this knowledge had come from. The story was no longer just about why one measurement was appearing in many places. Now, another strange question was coming up. Did the accuracy of this measurement increase or decrease over time? Normally, we look at history like a straight staircase. One generation learns something, the next generation improves it a little, and the people who come after them make the technology even better. In other words, as time moves forward, knowledge should also move forward. But in the analysis we are talking about here, the claim was that the pattern appeared to be the opposite. At Pumapunku, the measurement and geometry appeared to be the clearest and most precise. But at some later sites, the same pattern did not completely disappear. It could still be recognized, but its accuracy was no longer the same as before. It was as if someone had remembered an old formula, but over time had slowly forgotten its finer details. If this data is placed on a graph according to age and accuracy, the claim is that the line does not move in the direction we would normally expect. It appears to move backward. And this is where a very big question comes up. Was the oldest work actually the most precise? If that is the case, then it would mean that this technology did not first appear at Pumapunku. Perhaps an older knowledge was being used there, knowledge that already existed before them. And when that trend was taken even further back, it started pointing toward a time before Tiwanaku, then even further back, toward a time that we usually consider to be before the story of great monuments and organized civilizations had even begun. And finally, these lines appeared to reach toward an empty gap, a period about which we know very little. But the empty space these lines were pointing toward was not just an empty space in archaeology. It was also an extraordinary period recorded in geology. Now let's take the timeline back around 12,000 years. During that period, Earth experienced a climate change known as the Younger Dryas. It started around 12,900 years ago and ended around 11,700 years ago. It is counted among the fastest and most sudden climate changes of the last 100,000 years. Temperatures dropped quickly across many parts of the northern hemisphere. Some claims say this drop was up to 15 degrees Celsius, But this should not be considered a number that applied everywhere. Around the same period, many large animals, or megafauna, also started disappearing. Sea levels were also changing. And this is where the story becomes even more interesting. In 2007, a team led by Richard Firestone, along with researchers connected to Lawrence Berkeley National Laboratory, presented a major claim. In their work published in the Proceedings of the National Academy of Sciences, they discussed signs such as iridium, magnetic spherules, and nanodiamonds at some locations. Their suggestion was that perhaps a comet or asteroid had broken apart and hit Earth at that time, playing a role in this major change. But one thing is very important here. The Younger Dryas impact hypothesis is still controversial. There is little question that this climate event really happened, but scientists are still debating what exactly caused it. Now this is where our real speculation begins. Was there some advanced measuring or building culture present at the same time, about which we still do not know? According to mainstream archaeology, there is no accepted evidence for this. But if the different precision lines appearing in our machine keep pointing toward this same historical gap, then the question arises, are we just looking at a coincidence? If this is only a coincidence, then we have to explain why different precision lines keep returning to the same historical gap. And if it is not a coincidence, then the role of Pumapunku changes completely. If we put everything we have seen so far together, then the story of Pumapunku is no longer just a story about some old stones. On one side, we have a highly capable Tiwanaku civilization. They farmed at difficult high altitudes, controlled water, organized thousands of people, and worked with massive stones. So it would be wrong to say that they simply could not have built such a structure. But, on the other side, some questions still remain. How was such clean geometry created on such hard stones? How did the H-blocks become so similar? How did the surfaces become so flat? Why do the depth of the small holes and the lines inside them show such regularity? And if there was a common measurement or design behind all of this, where did that measurement come from? This is where the story becomes interesting. It may be that the answer is completely normal, and that we simply have not fully understood Tiwanaku's technology yet. Maybe they used a stone carving technique whose knowledge was lost over time. But there is another possibility too. What if Tiwanaku did not start everything themselves? What if they gained parts of some much older knowledge from before them, and then over time that same knowledge gradually became weaker? And if future research ever proves that the same measurement, similar geometry, and decreasing precision over time really existed in different places, then we may have to change the way we look at our history. For now, we have a mystery, questions, and some truly extraordinary stones. So, what do you think? Is Pumapunku a far more advanced example of ancient engineering than we imagine?